Hello students, welcome to the video class. Today let us learn about acids, bases and salts. In our daily life, we use large number of edible substances such as lemon, baking soda, tamarind, unripe mango, tamarind, sugar, curd, vinegar. So these are some of the examples of substance that we use in our daily life. So these food items or edible substance contains chemical substance in them. So these chemical substance can be classified into three such as acids, bases and salts. Acids can be again of two types, organic acid and inorganic acids. Let us learn about each of these in detail. Acids, bases and salts are the three important groups of chemical substance that are used by us in different ways. Some of the acids, bases and salts occur in nature and some are made artificially in the factories. Let us look at some of the edible substance and their tastes now. Look at this given image. Here is the image of lemon juice and orange juice. You might have tasted it many times. Lemon juice has sour taste. Orange juice also has sour taste if it is unripe, and if it is mixed with sugar then it tastes a bit sweet. Then vinegar, it tastes sour. Curd also tastes sour. Tamarind also has a sour taste. Sugar, in this image you can see sugar, salt, common salt and amla. You might have tasted this. Sugar tastes sweet. Common salt is salty. Amla tastes sour. Baking soda tastes bitter. Try to taste bit of baking soda. It has a bitter taste. Grapes, it can be sweet or sour. Now let us learn about acids and their sources. Here is a list of acids that are organic in nature. Let us learn the names of these organic acids and the sources in which it is found or present. Name of acid. Acetic acid is present in vinegar. Just now you have seen the image vinegar and you might have seen your mother using vinegar at home. That vinegar or the vinegar which is used at home contains acetic acid. Formic acid. Many a time you might have got an ant sting. So whenever the ant stings, it injects formic acid into our skin. Citric acid. It's present in citrus fruits such as oranges, lemons, etc. Lactic acid is present in curd. Oxalic acid is found in spinach. Ascorbic acid or vitamin C is found in amla and citrus fruits. Tartaric acid is found in tamarind, grapes, unripe mangoes, etc. Now let us learn about examples of some of the inorganic acids. Hydrochloric acid, sulfuric acid, nitric acid are examples for inorganic acids. Here is an image of hydrochloric acid, sulfuric acid and nitric acid. So you might have seen that these acids are used in the laboratory and it is also used in many of the chemical preparations. Acids and bases. The word acid has been derived from the Latin word acere, which means or derived from acidus, which means sour. Thus, all sour substances essentially contains acid. Substance like lemon juice, orange juice, just now you have seen in the image, Unripe mango and curd taste sour. They taste sour because they contain substances called acids in them. The chemical nature of such substance is acidic. The acids in these substances are natural acids. So we can call them as organic acids. So unripe mango contains organic acid. It tastes sour. That means it contains acid. Here is the image of lemon orange. It tastes sour. It indicates that this food substance contains acid in them. However, there are other substances like baking soda. This baking soda, it does not taste sour. If you test a bit by tasting a bit of baking soda, you can easily identify that it doesn't have a sour taste. That means it has no acid in it. It tastes a bit bitter. And if you prepare a solution of baking soda, if you put a spoon of baking soda in water and if you prepare a solution of baking soda and if you rub it between your fingers, it feels soapy. You can feel that you are rubbing soap between your fingers. You feel a soapy experience. So, this baking soda doesn't contain acid. Then what does it contain? Yes, substances like this which are bitter in taste and feel soapy on touch are known as bases. The chemical nature of such substance is said to be basic. So whenever you are feeling a substance, if it is soapy to touch and if it is having a bitter taste, then you can easily identify that that particular substance contains base in them. All the acids mentioned in table occur in nature, and here are some of the images like baking soda, and here you can see some of the materials or substance that we use in our daily life that contains base in them. Here is an image of milk of magnesia, then bleach, and another one substance that can be used as cleaner, and here is a gel, and even the Digene solution, the Digene syrup that we drink, all these substances contains bases in them. Now let us learn about bases and their sources. Just now we have seen the image of substance or material that contains bases in them and we use it in our daily life. Now let us look at some of the names of the bases and the substance in which it is found. Name of base. First is calcium hydroxide. Calcium hydroxide is found in lime water. Ammonium hydroxide is found in window cleaner. Sodium hydroxide or potassium hydroxide is the base and it is found in soap. Magnesium hydroxide is the base and it is found in milk of magnesia. Now let us look at the image of some of the food substance that has base in. Here is the image of some of the food items that contains base. Now let us learn what is meant by indicator. Every time we cannot taste and tell whether this given substance is sour, whether the given substance is bitter. Based on sourness and bitterness, we cannot always tell which is acid or which is base, because sometimes it can be dangerous to taste all the substance. So we need to use some material to test whether the given substance is having acid or base. So this substance are called as indicators. Indicators are of two types, natural and artificial. Now let us learn about natural indicators around us. Natural indicators. Here, look at the image. You can find the images of some of the natural indicators like lichens, turmeric, which is used in our kitchen. Every day we use it. then red cabbage, a vegetable, and hydrangea plant that indicates whether the acid is soil or base by changing the color of the flower. By looking at the color of the flower, we can easily identify whether the soil is acidic or basic. So some of the plants also act as indicator, and they behave as natural indicator and indicate or show us whether the soil is acidic or basic in nature. So here is the image of lichens. This lichens, by using the solution of lichens, we can we can use a solution of lichen as natural indicator, or we can even prepare a paper that is called as litmus paper. It is obtained in two colors, as you can see in this image, red and blue. Red litmus paper and blue litmus paper. So let us look at some more examples which we can perform at home, and we can test the substance whether it is acidic or basic. Some naturally occurring indicators are, just now you have seen litmus, turmeric, China rose plant, which is easily available in the garden or in the streets. There's many plants of China rose are found, and even red cabbage juice. These indicators show different colors in acidic and basic media. So they are used to test whether a substance is acidic or basic in nature. China rose as an indicator. We know that China rose is a natural indicator. It is also called as gudhal in Hindi. It is extracted from the red flowers of China by crushing the flower petals with water. China rose plant, red flowers of China rose plant can be crushed and mixed with water to obtain the solution, indicator solution. So we look at this image. Here is the flower which is commonly called as China rose. So if you take the petals of this flower and you crush and prepare a solution, it will look like this. Look at this given test tube that is present at the center. The solution of this China rose is light pinkish in color, and it will act as an indicator. After crushing the petals and preparing the solution, now we are ready with the indicator solution. Suppose if you have to test any solution whether it is acidic or basic, you can easily identify it by seeing the change in color. So suppose if you have taken acid in a test tube, and if you put few drops of China rose solution into the acid, it will give you tint or slight red yellow color. And if you put the same indicator into the base, it will give you light bluish green color. So by seeing the change in color, you can easily identify whether the given substance is acid or base. Litmus, it is commonly called as a natural dye, a naturally occurring indicator. Litmus, which is naturally occurring indicator, is obtained from lichens. This is a small plant, and it is used as a dilute solution also. We get litmus solution, and we can also prepare it by embedding the solution into the paper, which is called as litmus paper. Litmus has a mauve or purple color in water. In an acidic solution, it turns red. When it is added to basic solution, it turns blue. Look at this image here. So here is a litmus solution which is purple in color, and if the litmus solution is added to acid, it turns red, and same litmus solution if it is added to base, then it gives blue color. So litmus, which is a purple color indicator, if added to acid, it gives red color, and it indicates that the given solution is acidic in nature, and if it is added to base, it gives blue color with base. Now till now we have discussed about a litmus solution and how it will behave with acid and base, and we also discussed about China rose solution as indicator, which how it will give the color with acid, what color it will give with the base, we have discussed. Let us look at some other natural indicator now. Here is turmeric. Turmeric is another natural indicator. We all know that turmeric is bright yellow powder and it is obtained from plant. It is also called as haldi in Hindi. Turmeric contains a yellow dye. Turmeric turns red in basic solution. So if you are putting a pinch of turmeric in basic solution, then it will turn red. Dear students, now let us talk about and discuss about acid rain. Have you heard of acid rain? Yes. The rain containing excess of acids in it is called as acid rain. Emission of sulfur dioxide and nitrogen oxides from vehicles and factories. So due to lot of pollution, lot of gases such as sulfur dioxide and oxides of nitrogen are given to the atmosphere. So when these gases reach the upper level of atmosphere, it reacts with the water vapor in the atmosphere and it mixes with the clouds and it turns into sulfuric acid and nitric acid. Here you can see in the image the oxides of sulfur dioxide SO2 and oxides of nitrogen, which is coming out as a product along with the emission. Here it mixes with rainwater. Sulfur dioxide mixes with rainwater H2O and it forms sulfuric acid H2SO4. In the same way, oxides of nitrogen also mixes with rainwater H2O and it forms HNO3. We all know that sulfuric acid and nitric acids are the strong inorganic acids. When there is precipitation or downpour or rainfall, these acids fall along with the rain and such a rain is called as acid rain. Now let us talk and discuss about the effects of acid rain. If this sulfuric acid and nitric acid is mixing with rainwater and if it is coming along with the downpour or precipitation, then it is very harmful. We cannot imagine its effect. So if this acid rain falls on us, it is very, very dangerous, isn't it? Let us look at some of the effects of acid rain. Here in this image you can see the havoc caused by acid rain. Acid rain makes the water of lakes, ponds and rivers too acidic, due to which fish and other aquatic animals get killed. Fishes cannot survive when the water becomes too acidic. If the rain falls into the pond that contains lot of fish, the water also turns acidic and the fishes cannot survive. So they die. So it is very harmful to the aquatic animals. Acid rain eats up the leaves of the trees gradually by losing leaves. The trees die. Acid rain also damages cropland in the field. Suppose if this acid rain falls on the leaves of the trees or if it falls on the crop field, then all the crops will get damaged. It is very harmful to the vegetation. Acid rain also damages the metal structures like steel bridges and when the acid rain falls on them. Here you can see in this image how acid rain has damaged the surface of building monuments that are made up of marbles. So we also call this as marble cancer. Suppose if this acid rain falls on the beautiful white marble, it damages that white marble and it destroys the beauty of that white marble. Such condition is also called as marble cancer and it is caused by acid rain. Dear students, now we have learned about acids and bases. Have you ever imagined what happens if we know that acid is very strong, very harmful and base. Till now we have discussed about the nature and properties of acids and the nature and properties of base. What happens if we mix this acid and base in equal proportion? Then what may happen? Let us discuss now. Under the heading neutralization. Acids and bases are chemically opposite substances. Till now we have discussed and we have understood that acids and bases are chemically opposite to each other. So, when an acid is mixed with base, they neutralize or nullify the effect of each other. They cancel the effect of each other and it results in new substance that is called as salt and water. Whenever acid and base is mixed in equal proportion, it nullifies the effect of each other and it gives rise to a new product such as salt and water. Such a reaction where acids and base react with each other and give rise to salt and water is called as neutralization reaction. So when an acid solution and a base solution are mixed in suitable amounts, both acidic nature of the acid and basic nature of the base are nullified or destroyed. The resulting solution is neither acidic nor basic. So the reaction between an acid and a base is known as neutralization. In the process of neutralization, salt and water are produced with the evolution of heat. You can see here acid plus base react to give rise to salt and water. Here is an example. Suppose if we are mixing hydrochloric acid with the base sodium hydroxide, HCl, hydrochloric acid plus sodium hydroxide, NaOH. It gives rise to salt and water. The name of salt formed here is sodium chloride, NaCl, and water, H2O. Now, as we have learned about neutralization, now let us talk and understand more about one more type of indicator which we have not discussed till now. There is one more indicator called as phenolphthalein. Now, let us understand how phenolphthalein is helpful for us in understanding the acid and base, to identify acid and base. If dilute sulfuric acid is added to lime water, which is a base, then neutralization reaction takes place and the reaction mixture becomes hot. Now we are going to use an indicator which you have not used so far. It is called as phenolphthalein. Look at this given image. Here a person is using phenolphthalein as an indicator. Phenolphthalein is an indicator used in the neutralization process. When the solution is basic, phenolphthalein gives pink color. But if the solution is acidic, it remains colorless. So, during neutralization reaction, by using phenolphthalein, we can understand whether the basic content is more or the acidic content is more. So, phenolphthalein can be used as an indicator in neutralization process. Here in this image, you are learning that phenolphthalein gives pink color with basic solution. Neutralization in everyday life. In our daily life, we come across many reactions that involve neutralization. The neutralization reactions involving acids and bases play a very important role in our everyday life. For example, the treatment of an ant sting, remedy for indigestion, soil treatment and treatment of factory waste, all these involve neutralization reaction. Let us learn about each of this neutralization reaction in everyday life one by one. Let us learn about indigestion. In our life, we come across a problem of indigestion. One or the other time we have faced indigestion problem. So let us learn what is it. Our stomach, as you can see in this image, our stomach produces lot of hydrochloric acid. This hydrochloric acid help in digesting the food and also it kills the harmful microbes that accidentally that might have entered along with the food. Sometimes what happens is excess of hydrochloric acid is produced in the stomach. Suppose if you are not taking proper meal at the correct time, then this hydrochloric acid will become excess. It starts producing excess amount and it may result in indigestion. Due to indigestion, sometimes a person feels pain in the stomach and also irritation. So to relieve this indigestion or gastric problem, we take a tablet, antacid. So or we can take a syrup. So this antacid or syrup contains milk of magnesia. As you have learned in the previous slides that milk of magnesia contains a base, and the name of that base is magnesium hydroxide. Magnesium hydroxide, as it is a base, it neutralizes the excess acid present in the stomach. It reacts with the acid. Here magnesium hydroxide is the base and the acid produced in the stomach, hydrochloric acid, both acid and base react and it will neutralize the effect of each other and it converts that into salt and water. So in our alimentary canal, we can easily learn about this reaction, neutralization reaction that is naturally occurring in our system. Another antacid that we commonly use is baking soda. You might have seen elders at home. Suppose if you complain of any indigestion problem, they generally ask you to drink a glass of baking soda, which contains again a base, sodium hydrogen carbonate. So this base, sodium hydrogen carbonate, reacts with the water and it converts into a base and it will nullify or neutralize the effect of acid. Basic salt, it converts into a base and then it nullifies the effect. Now let us learn about ant bite. Look at this given image. When an ant bites, so here a person has got an ant sting or ant bite. So when an ant bites, it injects an acidic liquid into the skin of the person which causes burning pain. The sting of an ant contains an acid called formic acid. The effect of the acid can be neutralized by rubbing a mild base like baking soda. So whenever you are having an ant sting, you should immediately rub that area of ant sting with baking soda solution. Or this baking soda solution is nothing but sodium hydrogen carbonate solution, or you can also use calamine solution. So this calamine solution contains a base called zinc carbonate. It is actually a salt. Zinc carbonate is a salt, but if you dissolve in water, when it is mixed with water, it forms zinc hydroxide, that is a base. Thus, being a base, baking soda solution or calamine solution neutralizes the acidic liquid injected by ant and it cancels its effect. So overall what we are seeing here is acid which is injected, formic acid that is injected by the ant, the effect of that acid can be nullified by using the basic solutions. Let us now learn about soil treatment. The soil may be acidic or basic naturally. Here you can see in this image, if the soil is between the range of pH 6.2 to 7, the plants will grow very well. If it is acidic, too acidic acidity in soil is not good for the plant, and too much alkalinity or basicity is also not good for the plant. So soil requires a neutral pH of around slight 6.2 to 7. So here is a pH paper that indicates the pH of the particular soil or any other substance. So this pH paper also acts as an indicator. It indicates the pH of the substance. The soil may be acidic or basic naturally. The plants do not grow well if the soil at a place is too acidic or too basic. So by using this pH paper, we can easily test the pH of the area, and before growing the crops we can, if it is too acidic, by using the base we can nullify the acidity, or if it is too acidic, if the soil is too acidic, too basic, then we can add acidic salts to the soil and we can decrease the effect of basicity in the soil. So this pH plays a very important role in indicating the pH of whether the soil is acidic or basic in nature. Excessive use of chemical fertilizers makes the soil acidic. Because the farmers use excessive chemical fertilizer, that particular area, because of continuous supply of fertilizer that are rich in acid, the soil may turn acidic. So when the soil is too acidic, it is treated with base like quicklime. We can add the base quicklime, so that, or slaked lime, which is also called as calcium hydroxide. So these bases neutralize the excess acid present in the soil and reduces its acidic nature. If the soil is basic, organic matter called manure or compost is added to it. The organic matter releases acids which neutralize the excess base present in the soil and reduces its basic nature. Factory waste. When treating the factory waste, here also we introduce or we inculcate neutralization reaction. The waste substance discharged by many factories contains acids in them. If these factory waste are allowed to flow into water bodies like rivers, ponds, lakes, etc., then acid present in them will kill fishes. Just now you have seen in the image how the many fishes have died because of the effect of acid rain. And other organisms which live in the water bodies get killed because of the effect of high acidic content in the water. So factory waste must be treated by neutralizing it, by mixing the waste, if the acidic waste along with the basic substance, we can neutralize the effect of the waste and we can then release it into the water bodies. So in treatment of factory waste also neutralization reaction is used. Here are some of the keywords. Dear children, it is given in your textbook. Please write the keywords and practice it. Thank you. Have a nice day.